Okay, let's proceed with the next session. And Ivan Husarov will open this session. He was supervised by Sergei Yakovenko, and he will be presenting his work entitled MS-GPT Pre-training Transformer on Musculoskeletal Data for Movement Pattern Analysis. Ivan, please.
Thank you. Hello, dear committee, audience. They're going to present my master diploma, and which is called Musculoskeletal Generative Pre-trained Transformer for Movement Pattern Analysis. Let's start from the plan. Yeah. Plan default is the following, and let's jump just straight into the field introduction. So what is muscle activation itself? Muscle activations are essentially signals from the nervous system that tells muscles when and how much to contract to generate force. You can think of them as control signals that coordinate all movements when you walk, run, or even just stand. Nervous system is always working, and it's continuously sending these activation signals to different muscles. We can measure these directly using electromyography or EMG, or estimate them computationally through biomechanical models. And understanding these patterns is crucial because they represent the fundamental control mechanisms underlying all human movements. Here is image of how EMG sensors are placed on a human when we try to capture these muscle activations. And this process is kind of hard because you first need to buy the sensors, then calibrate them in some lab environment, set up these experiments, testing, and all of that. And of course, every human has its own scales of legs, limbs, yeah, etc. So we acquire some generalized model, and then we try to scale it somehow. And it is quite hard when we are talking about some public data, because we need to provide not only muscle activations, but also scaling data. And the second approach is to use biomechanical models to estimate these muscle activations. They are estimated from kinematic data. And this kinematic data is actually obtained with the same sensors. It can be obtained with cameras. And the main point is that we obtain this kinematic data, we obtain ground reaction forces. When human walks, he steps these force plates, which capture force initiated from human. And therefore, we can compute through inverse kinematics, inverse dynamics processes, we can compute muscle activations and muscle forces. What's about open source state right now in this field? We have OpenSim. OpenSim is a great tool to process this, to process muscle activations, to set up some experiments, etc. And what about OpenSim? What is also great about it that they have repositories with experiments. Therefore, we can there obtain this data. There's some open source experiment data. Also, we have Art Biomechanics. It's also from OpenSim. It's this kind of collection of experimental data where we can also take kinematic data, take some muscle activations, and process them somehow for our needs. And there was also presented muscles in time datasets. It's a great dataset which focuses on muscle activations, and the only thing about it is that it is synthetic. And as I said earlier, there is one problem with all of these repositories, datasets, is that they require you to have all the scaling data, scaling processes. You have to perform them yourself. So with all of that, we see that musculoskeletal modeling requires like extensive parameter tuning and this type of scaling. And this modeling is essential for understanding human movement, but currently it requires specialized knowledge. Our research addresses the challenge of generating physiologically plausible muscle activation patterns from natural language instructions, with which we are trying to bridge the gap between verbal commands and complex biomechanical parameters. Yeah. Here is what about related work. We currently have LSTMs, CNN LSTMs that try to prognose, try to estimate muscle activations from EMG data. But EMG data is noisy. It's noisy because these sensors are not obtaining clear activations. Yeah, they're always noisy because when you place the sensor somewhere on your muscles, there are also muscles around it that contract with it and create noise. Also, there was autoregressive transformer model, which takes text inputs and generates steps, some spatial data. This paper that I took this visual from is not about muscle activations, but it's about video generation. And in video generation, they tried to autoregressively generate movements in video using natural instruction. And once again, what do we think about when we are talking about like muscle activations, like some walking, limb, lower extremity? We can think and try to like sync it somehow with concept of deep learning. In deep learning, we have like this thing called tokens. And when we try to bridge these two fields together, we can see that predicting temporal multivariate data is pretty complex. That's why here in this paper, in this project, we introduced this type of token in musculoskeletal modeling, in walking, which is called gait. Gait itself is just a fundamental unit of walking analysis. One complete cycle from heel strike of one foot to the next heel strike of the same foot. This is standardized unit, and it is essential for this analysis because it's the smallest one that is repeatable. Here we can see that sequential units and building block and context dependent, like, I don't know, adjectives, both apply, all apply to tokens and also for gait cycles in the movement sequence. That's why in movement, gait is a high-level token, and we try to operate with it. That's why we propose our solution, which takes text inputs and then autoregressively generates muscle activations for walking. In this project, we are focusing on walking with different speeds. And walking can be straight, turns, we can walk backwards. There are also these gaits, and we have this data. We acquired it from muscles in time dataset. So our key tasks are to enhance and expand muscles time datasets and develop approach for generating these activation patterns, train model, and actually evaluate its performance. So let's talk about muscles. There are two types of muscles, flexors and extensors. Flexors account for our joints bending, and extensors are responsible for straightening the joint. From over 40 muscles in lower extremity, we are focusing on 5 because these 5 have the clearest activation patterns. They are not in counterface with each other. Therefore, we can model them because we can model them effectively, more effectively than if we picked some other group of muscles. So what about dataset generation? Our project focused on dataset generation parts and model training. What about datasets? We had muscles in time datasets, and for it we had ground reaction forces and muscle activations. As we are going forward with token approach, with gate approach, we are splitting these muscles in time datasets with ground reaction force, some thresholds. When human steps on force plate, some force generated, and we can split based on that. And after that, we performed speed interpolation between set of speeds that was in dataset to acquire some not universal, but more fine-grained type of data. And also we applied turn modeling. We performed central path generator framework. We applied to our muscle activations to model different type of turns. And also we added turns into our datasets. Here is datasets speed distribution. Speed distribution in datasets. We have this long tail, and we have this median somewhere over 1.4, 1.9. Yeah, it's around average human walk speed, meters per second. Yeah. And then we performed labeling with GPT-4o. We added this speed or movement type change labels, and based on them we performed instruction generation. And here you can see a whole pipeline of dataset generation. We generated 200K sample datasets with instructions, and we generated 500K sample datasets without instructions. Yes, and here's our architecture overview. For our architecture, let's imagine this instruction. Yeah, this instruction says keep walking steadily from one gate, speed up, and make a right turn. It means that we will have some predefined set of steps, which will have some predefined set of muscle activations. For this instruction, we can say that it is expanded into walk straight for like one gate, for one token for one gate, then then speed up for one gate, and we have this speed up and slow down labels. They are also added to dataset in terms of how to say it. In muscle study dataset, we researched difference in speeds and in walking speeds, and therefore we obtained some change in speeds, which would enable us to say that we speed up or slow down, like 0.5 meter per second change, or maybe less, 0.2, around that. And we, for input, we have instruction and initial gate cycle. Then we provided to our model autoregressively generating gates. Gates, speeds, duration, labels, because all gates are scaled to 30 steps to 30 steps sample. Yes. And here is our component description. We have input tokens, gate embeddings, positional encoding, which is also trained during our training step. Then we have transformer decoder and our prediction heads. For prediction heads, we have 4 prediction heads: gate prediction, speed, duration, and gate type, where gate type is cross entropy and all other are MSE. And here is architecture of the transformer. We have input sequence. We start with embedded inputs that includes both language and initial get information. This passes through 8 transformer decoder layers, each containing masked self-attention and feed-forward networks with layer normalization and residual connections. Crucially, we use casual masking to prevent tokens from attending to future positions and maintaining autoregressive generation with that. With this flow, first thing we did, we applied teacher forcing and scheduled sampling to fuse generated gates into training process. So we don't overfit on only ground truths because generated are much fuzzier and much noisier. We have a sampling strategy, which starts with fully training on ground truth at first, and then scaling to going like 0.9, 0.95 of predicted gates. And here are our first results. We can see that we achieved R-squared metric of 0.28 for mass fluctuation prediction, and this, yeah, it's quite low, I would say. That's why we tried to fix this, enhance this in future iterations. While this might seem modest, it's important to remember that mass fluctuation patterns are highly variable and noisy, even for the same movement. Then, what we did, we utilized pre-training. We utilized pre-training with this 500K data without instructions. We pre-trained our model solely on gates, also utilizing teacher forcing and scheduled sampling. And after that, we fine-tuned our model, transferring weights from pre-trained model and adding language bird encoded instruction at sequence out. And here are our results. We actually had some progress here because our squared is rose a bit, like 0.0405 points, and also for Pearson correlation coefficient and SMAPI. And after that, we added dynamic weight clause because we saw that having multiple projection heads, multiple prediction heads, results in having this large loss function, which consists of multiple smaller loss functions, and some of losses converged dominantly. They were clearly dominating and started overfitting and stopped resulting into this training process with their loss metric. That's why we applied dynamic weight loss. We identified label cross entropy prediction as the most dominant, as the fastest overfitting, and we identified gate prediction, gate estimation as the slowest conversion loss. Yeah, and for this one we achieved quite a bit better results. Yeah, it's like 0.38 for R-squared. But also here in dynamic loss, we identified that some muscles converge faster if we try to apply this weighted loss not for all gates, but for some group of muscles. We can apply for extensors and flexors because they are counterparts, and that's why we can treat them a bit differently. So we found out that extensor muscles are more dominant, and this is quite a good, I don't know, thing we found, because from that we can apply some explicit, we can assume we can apply explicit bounds and some explicit rules for losses. And here's our evaluation results. We also trained LSTM baseline, which performed poorly because we didn't utilize token-based prediction. We utilized just multivariate temporal prediction for LSTM. And with all of this, we had this pre-trained transformer with weighted loss performing the best. What about some analysis? Here we have one muscle's gastrocnemius medial and its activation for 3-gate example. And we can see it is quite noisy. It's quite noisy because ground truth reaching almost 0 and reaching and have peaks at almost 1. But our predictions, while following the main trends, but it's too noisy. And here we can apply to error accumulation because we found out that with autoregressive generation, tokens we generate later, the more noisier, have bigger error, and much more imperfect. And what's our observation? It's flexor-extensor loss imbalance. That's what I said about different muscle groups. I think with proper research, we can apply this weighted loss or maybe some other restrictions in time of training for some other groups of muscles. And our key contributions are data sets. We open sourced it. It can be found on Hugging Face. It has natural instructions, gate labels, and what we discussed. Yes, and also we open sourced artifacts for models. For our latest model, this pre-trained with weighted loss. And our results that we moved from 0.29 to 0.41 with these iterative refinements of our approach of our training process. We improved also gate label accuracy with dynamic scheduling because it's not overfitting anymore. And we found out that we achieved better convergence for gate transition prediction. What's our limitations? Are dynamic loss influences only large muscle groups? We can somehow set explicit rules for smaller groups, maybe if not single muscles, but maybe smaller groups, not only flexors and extensors. Also, we have this uniform sequence weighting, regardless of prediction horizon, and we don't currently employ progressive weighting, which would account some weighting rule for next token generation, maybe some other weighting rule for second, third, etc. tokens. And yeah, we still see this performance degradation in longer sequences. And for future directions, it would be great if we yeah, if you reviewed attention map insights, had this sequence length dependent weighting. Also, we could expand our datasets with more fine-grained activations, and we could train on full muscle sets to imply physics-based simulation integration, because right now we cannot do it because we trained only on subset of muscles, and physics simulation would not simply work because we cannot right now estimate other muscles. And what about applications of this approach? Its main application is using in virtual environments, in some educative materials and educative tools. We can, with this approach, we can create some small-scale data sets for some specialized movements, maybe like going in circles or moving backwards, etc. And these data sets can be applied for product testing if you're focusing on some single muscle groups, or if we extend our project, whole lower extremity muscle group. Thank you.
Anybody would like to start?
Thank you, Ivan. Can we start from understanding what is going on from the very beginning? So as far as I understand, there is the problem. So can you jump to this picture when there is a person standing with all these controllers, attached? So you want, as far as I understand, have a model that it as input it has like instruction in natural language of doing something. So what is actually we want to do? So it's we want can you elaborate on this, because I don't want to interpret.
Sure. We want to have instruction which model takes and generates muscle activations of muscles. Actually, these
activation muscles for what? So we have Android, or we have a human with attached those some, I don't know. So what is this device? What's the proper name for devices we work with?
We work with lower limb, human lower limb. I don't know how to say it. It's just muscle activation, because muscle activations are not muscle forces. Because muscle forces results in some torque.
So is it correct to say that we artificially activate muscles?
Yes.
With these devices?
These devices capture muscle activations.
Capture.
And they capture it, human puts it on it.
By this setup, we collect data.
Yep.
Yes. And then there is another device that used to be to activate muscles.
Another way to simulate muscle activations.
Simulate muscle activations.
Yes.
Okay. And then, so your model, your setup, for how many different muscles? So I want to understand the scale of the of your setup. Is it like for one muscle and or for a set of muscles?
It's for a set of muscles.
How many?
Right now it's for 5 each leg. But in ideal world, it's for.
So we deal right now. We deal with. Okay. So can you jump for the probably when we have
this one.
So we work with the lower limbs, as you mentioned, and we have for 5 muscles per each leg.
Yes.
And then so again, the input for the model is the instruction, and the output is the what? So how to say? Not instruction, but a set of signals for the muscle activators, or how to say?
Yes. Yes, I would say that we have natural, we have instruction, and from that we simulate activations of muscles that could be captured with these devices. But we do not need these devices because we simulate these activations.
And how we represent muscle activation in data. So I want to understand what is output format.
Okay, output format is a time series sequence of values from 0 to 1. And
how many values in the sequence?
For 2 steps, we have 30, but also we have scaling parameters which depend on the speed.
It's 30 for each muscle or
30
altogether?
for each muscle.
So, and when to have calculations, so again, so how many? 5 per each leg, it's 10, and then 30
it's
for each
300.
step, 300, right?
Yes.
Okay, it would be benefit if you have the example of those input and output to bring all together. Okay, I'm stop here so far.
Thank you for your presentation. Could you please clarify for me some technical details? It looks like typical sequence-to-sequence model. You have text output is this, let's say, feature activations. Why you use this approach?
Because yeah, we could go with approach with encoder-decoder approach. We could first encode our instruction and extract this, I don't know, like some labels, and from that we would have predefined length of prediction. Yeah, of number of steps we need to predict, like in instruction.
But yeah. Here, what the input of BERT encoder? It is just a constant vector of embedding of this instruction.
BERT encoder just embeds the instruction. It's just a frozen. Yep.
Okay. And what next gate flattering? What is this?
We have this initial gate cycle to preserve some specific to patient muscle activation patterns. We flatten this 30 by 10 metrics into this 300 length sequence.
Okay. We are not close to my main question. If I have sequence-to-sequence model, yes. I have encoder, transformer, decoder, and cross attention between them. How you transform this information to your decoder? Where you inject this information? It's not clear for me from this picture. So how you feed this information to your model? You have a 6 layer.
8 layer.
8, okay, sorry.
And before that, we have this positional encoding.
Here. So you have your features, then concatenate at each time step this embedding feature, and
yes. And we positionally encode them.
Yeah, I understand. And then you predict next step. But when you use pre-training step without this information, what you feed to your but your model during pre-training, she has some input size.
Yes.
I'm worried in your pre-training stage, you don't feed text information. How you deal with input?
After on the fine-tuning step, you mean?
Yes.
Okay. For the fine-tuning step, we provide textual inputs as.
But at the first step, what you provide instead of text?
There is no instructions.
Yeah. So your model should have, for example, 5,000 or whatever vector of this dimension during fine-tuning step,
yes.
And input size during pre-training. If you don't feed text, or maybe you feed zeros or whatever.
Maybe I'm missing something, but for
get back to the architecture slide.
This one, yes.
So it should be some input of this.
About embedded input of the training stage.
Embedded inputs. Here.
I'm afraid that they should be they should have different dimensions, and how we deal with this? Just my curious.
Okay, if you're talking about fine-tuning step after pre-training, only pre-training. For pre-training, we are stacking these muscle activation inputs.
With what?
One with each other, and feed them into positional encoding, which is also trained during pre-training.
Okay.
And then
okay, maybe you use just some additional projection layer to keep dimensions. Okay, so thank you.
Yeah, it's.
Thank you.
So the question is that your input for pre-training and fine-tuning should be the same, but it looks like during pre-training you use only without, as you state, without text, but fine-tuning with text or something like that. So how did you match this input dimensions?
Okay, I understood. Input how to say this? Textual inputs is also passed into positional encoding during the fine-tune step. Not during pre-training, but only about pre-training. Okay. So we do not need to think about okay, we need to think about fine-tune when we're doing pre-training, but the main idea is that we are stacking.
Do you have an example of how you concatenate position according to an embedded?
Not right now. Not right now, not in presentation. I don't remember actually.
Okay. Anybody else?
Yeah, I still have a couple. Before I pose my question, could you please clarify what is the input into the model and what's the output of the model? My interpretation is that the input is a high-level instruction, just go and bring me a cup of coffee, for example. And the output is the detailed sequence of muscle activation signals. Is that correct?
Yes, it's the output. And for input, we have the specialized instruction, not this type of general, like take a cup of coffee, but walk or rotate. And we also provide
a structured prompt, yeah?
Yes.
Okay. So then, well, it's rocket science for me. This is why I'm going to ask naive questions, not like taken from this notebook, Ellen, but anyhow. My first question is that you mentioned that you used a very noisy data set for pre-training. To think about denoising the data set in a way, well, first, is it possible at all? Secondly, did you think about that? And thirdly, would that improve the quality of your result? What's your backbone feeling?
I think it would improve, and we performed naive type of denoising without any temporal and like some transformation. We just dropped out samples that were out of our not out of our scope, but we performed isolated forest technique to remove outliers and kept only like 60% of our data set.
Did I understand it correctly that the main reason of this noise is sort of interference of the signals by the other muscles surrounding the one you're looking at?
If we are talking about data sets we used, it utilizes synthetic muscle activations. and they are not that. There is no such great inference between different muscles. But if we are talking about real imaging data, of course, there is a great impact of other muscles contracting with the one we observe.
Okay, thank you. So my second naive question is about the application of this approach. I just thought that if you were successful and learned to generate these muscle activation signals, there's only one beat disallowing you to zombie people, like invaded troops, just taking them all and letting them go and jump from the top of a cliff. Would that be possible, having your technology?
I think in terms of simulation, yes,
Yeah,
we could do it.
in terms of simulation,
Of course, in terms of simulation.
we're civilized people, yeah. Yeah, just for pure academic interest. Yeah. So did you think in terms of downstream applications of this technology? This is the sense of the question.
The main application is using it in virtual environments. And yeah, because the metrics and results are not that accurate to use it for real patients right now. And it could be used in ideal situation if all these issues I outlined would be resolved. It would be used, it could be used for some education, also in like the instruction, as you said, working in virtual environments, maybe some training, and maybe it could be used for product testing. That I thought, what I thought about, maybe a product that uses some group of muscles or some actual muscle.
Prosthetic development.
It could be. It's also product testing, but maybe not for a whole product, but for some small parts of it.
But I
Just
ask a couple of questions because we are short.
My very last and very quick question about the extension of the technology. It looks like movement planning. Did you think about using sort of reinforcement learning approach to improve your results? Just yes or no?
Yes, I
Okay,
thought.
Thank you.
Thank you, Ivan, for the presentation. I have also maybe a naive question. You deal with medical data. How big is variability between different persons? So is there, and if the data by nature are have variability, so what do you consider a good?
Okay. Thank you for the question. I understood, and what I can say that there are similarities between different patients, and we can see this at the data sets. Yeah, here we can see here are averaged muscle activations for some muscle in terms of a step, and you can see that there are differences in different patients, but they all follow some general paths.
Okay, and then given that variability, could you just take one standard pattern for one instruction, like go ahead, one gate, and then concatenate, add noise, or some other augmentation technique? What for do you need these neural network to?
The main idea is that we want to preserve concrete patient patterns. That's why when we for the input layer, we pass not only instruction, but also initial gate cycle, which is required from user. And that's why the subsequent generations would incorporate patterns from the initial one.
So do the same with these chunks of movements.
But if we concatenate the same chunks of moments for different people, it may not fit, because like activations for like a child, for older human, for like different age, different mobility level are different. That's why it's not just a concatenation of some standardized, maybe averaged muscle activation.
Thank you.
I have only one question. I'm thinking about a practical implementation of your solution. What do you think? Exists a lot of different type of wearable electronics. There is T-short, for example, with sensors. How to transform your solution to detection of, for example, fatigue or disease for elderly people or for soldiers or something like this?
Thank you. I would say that it could go into these parts of future directions. Where we wanted to somehow capture this sequence length dependent weighting for longer predictions, and maybe this kind of fatigue could be also somehow incorporated into the model. Yes, yes, with every subsequent gauge cycle.
Okay, a couple of quick questions from my side and then one from the audience. So I will ask a more concrete question. So in your text, you say that you use autoregressive decoder transformer with a causal masking. Could you please explain what is the causal masking?
Causal masking is a process where the decoder doesn't see future tokens. It only sees itself and previous.
Okay, and could you please explain how did you implement a positional encoding?
Positional encoding, actually, I used my third version of positional encoding, but as you know, it's just a table which is trained during training process.
Okay, and my last question, so you are the only student who didn't provide answers to reviewer questions. So have you seen your review?
Yes, I've seen my reviewer questions, and actually I have answer for one reviewer, but I haven't completed answer for second reviewer, and I thought it would be impolite to send a review to a response to only one reviewer, so I decided to take a bit more time.
I want to jump back to your contribution. So is it correct to say that the data set was provided by the Sergei Yakovenko team?
No, data set was not provided by Sergei Yakovenko.
So how you created the data set?
We used muscles in time data set, which was created right like several months ago during our research. We found it.
Whom?
Mine and Sergei Yakovenko.
So, but did you have access to those simulator you mentioned?
OpenSim. This first one, yes.
So all data is generated by OpenSim?
No, OpenSim is just a way to generate data. It's just a program that allows us to do it.
Again, your data set is completely synthetic, is it correct?
Yes.
So you generated data by using OpenSim?
We used muscles in time. They already provided synthetic data. And what we did, we interpolated it, we cleaned it, and labeled and provided natural instructions.
On top of the
muscles in time dataset.
And then you picked the existed model BERT, right? So the BERT architecture existed, right?
I used BERT only for natural language embedding. Yes.
Yeah, so back to your contribution. Can you sum up on this?
Mm-hmm.
Your own, not other involved persons.
My own contribution?
Yes.
My own contribution is first one, data set cleanup and labeled data set creation, which has this 500K and 200K data sets. And second contribution is this model that I assembled using BERT and GPT architecture, because BERT is used only for embedding, and GPT architecture is the backbone of the project.
But did you use GPT architecture from the shelf?
No, it's implemented, but I used transform decoder model from PyTorch, this positional encoding from PyTorch.
Do you have justification of why do you use this architecture?
Maybe I can explain.
Yeah, have you experimented with other architectures?
I have only one experiment with LSTM architecture.
You mentioned this as a baseline, right?
Yes.
Okay.
What about this physiologically informed loss function? Is it yours? I think it's very interesting, important, and it's
yeah, physiologically.
I think it's real. Could you explain it?
Yeah, of course. About physiologically informed loss function, that's what was the question of reviewer about. Also, because reviewer mentioned that's maybe implicit, like dynamic weighting and manually putting some bigger weights for flexors and lower weight for extensors is this explicit physiologically informed loss, but maybe
Thank you.
explicit would be.
It's like physical informed neural, not networks and physics. Here you introduce new loss.
I tried.
Thank you for the presentation. Can you please come back to the slide 21? Am I correct that your main objective is to predict these gates and like speeds, durations, and latents are kind of auxiliary outputs that like not the main aim of your research?
You mean speeds, durations, and labels?
Yeah,
yes.
Yeah.
No, they're not, because having speeds and durations help us scale the result, because every gate, every token is in this 30 data points time frame, and that's why we can scale with speeds and durations.
Oh, okay. I was just curious that you have mentioned that there was problem with balancing losses, so maybe you can just drop even some tasks and and your model and you will solve like the problem of one optimization, not like several aims. And I think the second quick question, you have mentioned previously about some sampling strategies with teacher forcing and with like some advanced approach to sampling. Did you try to make some ablation study of the effect of this approach? Because at the very end, you have mentioned that your model still struggles with very long sequences. So maybe did it help, or maybe you need like to tune it to for model to work with longer sequences?
Thank you. That's a good question, because I actually didn't perform ablation study. It would be great, but maybe I just haven't got there yet.
Okay, thank you.
So the next Presentation.
Oh,
Let's take microphone from Ivan not to hear some secret information. I think that for the next presentation, the microphone is especially needed because it is dedicated to audio, and maybe we will even hear some sound effects. So let me introduce the next presenter is Anдрій Шевцов, who is supervised by Volodymyr Sidorsky, who is, by the way, also present here. And Anдрій will be presenting his work entitled Bird Vocalization Generation Using Deep Learning. Anдрій, please.
Yeah. Okay, so good afternoon, respected committee and guests. I am Anдрій Шевцов, and today I want to present you my thesis entitled Bird Vocalization Generation Using Deep Learning that was supervised by Volodymyr Sidorsky. So first of all, I want to express my deep gratitude to my supervisor, to Ampersand Foundation for funding my tuition fees, to Zvuk and the Alliance of the Nova and MK Consulting for providing their computational resources, to all the participants of the subjective evaluation study, and last but not the least, to the Defense Forces of Ukraine for ensuring security that is essential for performing research at all. So yeah, please note that presentation will contain several brief audio clips. So listen to the following sound, please. Oh, maybe it. 1 second. Maybe now. So if it sounds familiar to you, that's because filmmakers use it everywhere from 1917 movie. Like it, I will not allow audio for now. And Harry Potter 3 at this moment, and also to Godzilla, Game of Thrones, etc. But in fact, it's just a common loon bird. So maybe instead of repeatedly disturbing like wildlife environments, like we could, to capture those sounds, we could just generate those sounds by ourselves with the same richness and variety. And this is the question that was driving this research. So we will start with providing our motivation for this topic, then come to the background on ecoacoustics and state the problem itself. Then we will come to our approach, including datasets, modeling, and evaluation of results. Also, we will listen to several generation samples. And finally, we will conclude the talk. So most work in audio generation, it targets either highly structured sounds, such as speech and music, or unstructured ambience, such as just general environmental noise. But bird vocalizations sit between those extremes. So they, in fact, have some inner structure, but they lack a standard way to be like encoded or be conditioned on them. So this gap is explored in this research. Also, a second driver for the work is the rise of ecoacoustics. So passive recorders here like monitor climate change, track biodiversity, and flag threatened species. And but collecting enough clean audio, like especially for rare species, is like costly and expert-related work. So our sounds, like generated synthetic sounds, can like this just make ecoacoustics model be trained easier. So they can augment the data sets and even lure like target species to stations for them to be explored in a non-invasive way. So interest to this field has risen with such websites such as Xenocanto and iNaturalist, and also with Kaggle competitions such as the BirdClef series. And that's why a lot of high quality and extensive data is present publicly on the topic, but for classification mainly. Like as a result, also many bird vocalization classification models exist, and the BirdNet is like the most popular. It covers 6,500 species worldwide and takes 3 seconds of 48 kilohertz audios. And also it is fully open source and open weights. Up to our recent knowledge, the only dedicated bird vocalization generation model is EcoGen. So it is a wiki-wide 2-based model. And either it is, although it is like quite fast and compact, it is an unconditional generation model. So meaning it cannot synthesize some species directly, but it like also is proposed to interpolate existing audios in the latent space, so to create specific species. But it limits control of this model and its realism. Moreover, it uses a Griffin-Lim-based spectrum to audio conversion to produce raw audio, but it creates artifacts. And together, this makes this model to be hardly compared with class conditional generative models. So let's state the problem. Research questions that were tackled in the study are which conditional generation architectures yield the most convincing generations? How do state-of-the-art text-to-audio models work on the unifying benchmark for this task? How well do those models generalize to multiple species? Also, can synthetic data improve classification for acoustics, especially for rare species? And finally, which objective metrics are the most related with human perception of this task? And the goals of the research are to create a state-of-the-art conditional deep learning model for the task, to design a reproducible benchmark and evaluation framework, which includes both automated and human-based metrics. Also, to develop a standardized data preparation pipeline and to demonstrate that synthetic data can improve classification, especially for underrepresented species. So we'll start with datasets. So our approach builds on 2 key datasets. It's BirdSet subset M. It consisted of 400 species and 1,300 hours of audio. And also BirdClef competition rare bird species subset. So it is just species with 100 samples or fewer in the dataset. So it is almost 60 species and 30 hours of audio. So both datasets are prepared for classification. So we need to adjust them for generation. So we therefore propose this custom data preparation pipeline. So it starts with a quality assessment step, then a model-based denoising step, and finally a subset split that is tailored to species frequency. So in the quality assessment step, we evaluate the clarity of each audio and also accuracy of its labels. But fortunately, both datasets contain human-labeled quality scores and also secondary species labels. So it makes this step be fairly automated. Next, we can apply model-based denoising. So we use the BirdNet, and each second of audio is scored with the maximum classification probability from BirdNet, like using sliding window approach. So we can see a male spectrum of some birds' vocalizations. Then here is probability scores of BirdNet for each second, respectively. Then, you can notice that probability spikes of BirdNet correspond to main bird vocalization patterns. And then we can use threshold and the DBScan styled algorithm to like find noisy parts of this audio and like noisy chunks and like filter them out and leave only meaningful audio bird vocalizations. And finally, we can perform a subset split. So we have like common, uncommon, and rare species. Like we treated common species as species with 100 samples or more in our dataset, and they are found only in a bird set, the dataset. For uncommon and rare species, uncommon have 50 to 100, and rare have 50 or less. For example, for common species, only high quality and single labeled bird vocalizations are put into test and validation sets, while, for example, for rare species, we omit validation sets fully to maximize both train and test sets, and like lower quality or maybe just like with secondary species, samples can be put into the test set. Okay, so talking about modeling, like several approaches to conditional bird vocalization generation were tried, including using existing text-to-audio models for inference, but it requires prompt for generation. Also fine-tuning TTA models, adopting their architectures corresponding to birds, to our task, and powerful fine-tuning of those models, and finally creating a custom model from scratch. So text-to-audio models used are state-of-the-art like models like Making-Audio 2 and Stable Audio Open 1. And like generative prompts were either constructed from bird scientific or common name or generated using large audio language models, LLAMs. So among 3 tested LLAMs, like Audio Reasoner have provided the best results on manual testing with 4 prompts and 10 random long audios. But due to a high generation time, it's only 5 long audios for each species were chosen and then used as class anchors to like for the descriptions to be used for all class audios during generation and training. So to illustrate that, here is example prompts for the black-cored hawk. So a common name-based prompt is just bird song of a black-cored hawk. A scientific name-based prompt is a bird song of Bizalarius nigricollis. And Audio Reasoner generated prompt is like a more detailed description with some like descriptions of bird voice patterns and also like similar sounds similar to these birds vocalizations. So now we can also fine-tune a TTA. So we have chosen a Stable Audio Open 1 because it is like an open source model with a very flexible architecture. So we have used generated prompts and we have trained like second level embedders and also the main diffusion transformer. And like this fine-tuned Stable Audio Open fine-tuned, we call it Stable Bird Text Model. Next, we can adopt this model to our like class conditional setup. So this was achieved by replacing clap text encoder from the previous slide with this class embedder. So we just an embedding layer plus a multi-layer perceptron. And we have proceeded with fine-tuning with 2 stages, starting with like only class embedding and several layers of diffusion transformer be trained, and then like all the latent model was unfrozen and trained for the rest like of the epochs. And this variant is, we call it Stable Bird class model. Also, lastly, we developed a custom model from scratch. It is a rectified flow unit trained in the Mel spectrum domain. So it includes a dedicated multi-label class conditioning layer, and also a big run vocoder, like following Making-Audio 2 to convert spectrograms into waveform audio. Like then, after generation, we can use generated samples for classifier training. So for that, we can use several sampling strategies, and compare them just to choose the best generated samples for each species. So for example, uniform sampling is like the most basic one. It is an equal number of generated samples are selected for each rare species and added to training data. Filter sampling, here we remove duplicates or just unrealistic samples. So we do it by calculating BirdNet distances in a BirdNet embedding space, and samples that are too far or too close to real samples are discarded from classifier training. Then filter limited, it is a stricter version of filtered sampling, and we further limit the number of samples for each class by just the number of real samples, so that like generated samples do not overflow real ones. And finally, filtered oversampled is the inverse approach to filtered limited. So here we try to flatten class balance, and to do that we add more samples for classes, more generated samples for classes with less real samples, and vice versa. And now let's come to evaluation. So evaluation contains both objective and subjective metrics, and starting with like embedding-based metrics, like at its core. So we have used an inception score with BirdNet classifier outputs, and also free-shank kernel distances in BirdNet and Codec and LeonClap embedding spaces. So BirdNet captures bird-specific features, while encodec tries to capture audio-related features, and CLAP tries to capture like text description-related feature of this general audio sample. So on this slide, we present a comparison of TTA models and like our proposed models too. So at the top, we have 2 rows displaying results for real audio. And then we have an EcoGen like inferenced in interpolation mode, like serving mainly as a reference. And then we have our class condition models, so stable bird class interactive flow model, where we see that stable bird class outperforms rectified flow on BirdNet related metrics, but is worse on encodec and CLAP based metrics. And like at the bottom, we have text to audio models, so our stable bird text and also stable audio open and make an audio, where we see that stable bird text outperforms other models on most of the metrics. Then we also like tried to make some classification-based metrics. So we followed BirdClef competition evaluation protocol and used Rock-Oak score as our main classification metric. And also we have used an efficient net-based classifier that was designed by my supervisor, and that was trained for 5 epochs on rare, like mainly for rare species classification. In addition, we just fine-tuned our class-based models on rare species, and stable bird class has shown like much better performance here. And here is the impact of like here's a baseline that was trained just on competition data, and then for models with 4 different sample selection strategies. And like they were all assessed on a single fault model on a validation set, and then 2 most promising was chosen to be trained for on 5 faults, and also to be sent to public leaderboards of BirdClef competition. And although like on validation sets the difference is minimal, but on a public like we have a 1.5% public leaderboard improvements for BirdClef competition. Okay, and we also decided to complement like objective metrics with subjective ones. So we have performed a subjective evaluation study using comparative mean opinion score metric. 60 pairs of 3 models and ground truth samples like were evaluated by like they were from 10 classes, like 4 common, 3 uncommon, and 3 rare species. And more than 60 listeners provided their 940 ratings, like with at least 15 ratings being provided for each pair. And they used a 7-point scale where the +3 means that the first sample in the pair is much more relevant to the reference than the second one, and like 2 - 3, that it is vice versa. And results showed that ground truth is still clearly distinguishable from generated samples, but at the same time, state-of-the-art TTA model stable audio open also has a huge gap to our fine-tuned model. And our stable bird class and rectified flow unit, they're much more species relevant, and but they're quite close to each other by relevance to the species. Also, during evaluation, we discovered that all distance-based metrics across all the embedders, they show like the same pattern, that they negatively correlate with the number of samples per class. So that means that rare species are harder to generate for a model than like common species. So it's quite logical, but yeah. And finally, it is a correlation analysis between like subjective and objective metrics. So we have at the top we have Pearson correlations of CMOS and embodiment-based matrices, and at the bottom corresponding p-values, so like they're not non-zero. So the results confirm that first of all, BERNet-based metrics correlate the most with relevance, like human perception of relevance, and encodec-based metrics are the least related to this. So let's try to listen to bird sounds. So here is a common bird called red eye warrior, and we will start with its real sample. So we can see that it is characterized with like not very frequent, but high-pitched chirps. Then let's listen to stable bird generation. Rectified flow generation. And stable audio open generations. So so we can hear clearly that stable bird and rectified flow are quite relevant to this bird, but maybe rectified flow has fewer background sounds, and stable audio open can even know this bird, but it mixes it with multiple other species. Then there is an uncommon bird called scrub tanager, and here it is its real samples. Here is stable bird generations. And rectified flow generations. And finally, stable audio opens. So pattern remains. So like both fine-tuned models are doesn't mix this species with other species, and probably like in this case, rectified flow even has a more reliable generation, but maybe it is just so too long for this bird's characteristics. And finally, a rare species called black-faced continga. So it is characterized with this like mediating vessel that contains like several chips and stable birth generation. So it tries to follow this like increasing pattern, but it cannot create these mediating vessels that ground truth has. Then rectified flows generations. So here they're much more close to ground truth, but also that may be too long for this bird just to be able to sync them. And stable audio opened here are completely not relevant to ground truth. So to conclude with this, we contributed to the field by proposing a data preparation framework, including our model-based denoising approach. Also, we established a comprehensive metric set for the problem and conducted a subjective evaluation study. Then we have set a strong baseline for the task and compared several TTAs and training fine-tuning approaches for the task. And also we demonstrated practical value for ecoacoustics, mainly for classification improvement in the sphere. Talking about limitations and future work, like a bird-specific vocoder model can be trained. Also, maybe other generative architectures, like not only diffusion ones, but like GANs or normalizing flows, etc., can be tried. Also, some advanced conditional strategies should be tried, including some like time-based conditioning of bird sounds. Also, it is needed to increase species coverage, as only 400 species were like the biggest data set that was used during the study. And like maybe some bird-specific evaluation metrics should be proposed, and transition to other classes such as amphibians, insects, etc., could be studied. So many thanks for your time, and we'll be happy to take your questions. And also you can listen to other generated samples on the website by the QR code.
Anybody would like to start? Okay, I planned to scan the QR code to visit the website, but since there are no questions yet, I will start. So I'm curious about the distribution of bird sounds in the data set. As far as I understand, there can be maybe some clusters within the data set that are similar to, say, they can be smooth and some can be other. Have you performed except for you know, rare, common, and mid species, have you performed maybe some analysis across different clusters of birds sounds within a data set?
Okay, so like it wasn't explicitly made, but like we have in subjective evaluation.
Like your code is not working.
Yeah, it's that.
Yes.
Sorry. Okay, so talking about different bird sounds. So they was not explicitly tested in this way, but a lot of different sounds were like used in subjective study. So like something like crows that were like making like car, and etc. So it was like 3 or 4 different styles was like evaluated there, but not like that it is better for more frequent sound types than for the less frequent or something like that.
Yeah, maybe as yet another ablation study, it would be nice to see across what categories of sounds. I don't know if they can be somehow classified. And one of my favorite questions that I ask about the examples in your presentation. Have you somehow manually chosen them from the results to sound nice and to maybe you know, try to disinform us that your generations are nice, or were those examples randomly sampled and inserted in the presentation?
Yeah, so it was on the website that like should be on this QR code. But yeah, it's a great question. So like random classes were chosen for presentation, and for each method, like three random audios were chosen, and the best one among them was like put on like to show to you. Yeah, so it's like semi-random approach here.
Okay, so I'm done with the questions. Just a small comment that I'm glad to see that we have also some kind of environmental caring presentations during our master thesis.
Thank you for the very interesting presentation. I'm just curious, you mentioned user study with human evaluation. Who were those people? They have some experience with this problem, or just your friends,
Yeah,
random people?
Great question. Yeah, it's mostly random people, as we have no access to real ornithologists. But there were several professional, how is it called, audio engineers, so like this, like involved in the study. So they were also, but like as a common listeners. Not.
Thank you.
Yeah, actually, I was one of the guy, and I listened samples on my high-end acoustics on my home. So, actually, yeah, as far as I know, several different people. Yeah, and my question is regarding the study, actually. Sometimes I had a feeling that I can decide which one better, not by the sound itself, but by the background noise or like another species present in the audio samples. So my question is, do you or do you not somehow do more high-end filtering for the study? I don't know, to generate noise where it shouldn't be, or to remove noise where it was, or to remove secondary species from the audio clip that was in the study?
So like all the ground truths like were like ground truth references for the study were chosen so that there is only a main bird present there. Also, like talking about generated samples, like there wasn't like any additional post-processing for them. So, and also actually the question like taken like to the audience, to the listeners, was like, like what is the what of the samples is more relevant to the reference sample. So that's why I like just supposed that background noises are not.
My concern is just like that in some cases when we do have like strong background noise with clear presence of secondary species, that's like it's more likely to be ground truth than generated, because as far as I see, generated for like more clear, more denoised. So like maybe these evaluations are slightly biased with the noise or with secondary species here.
Maybe, but also we want, like for example, for classification, we also want maybe more this noisy samples than more like pure laboratory ones. So, and also stable bird class that performs better, like it actually has this behavior, so it creates more noise than rectified flow models that like showed a little bit
yeah, okay, thank you.
Result.
Thank you for your presentation. I do have one maybe tricky question, and one is just for fun. The for fun one is whether it's possible to mix up multiple birds into one sample and like create some sort of music band of birds or something like that. And another one is whether the solution can be scalable to other domains, like I don't know, generation of music instruments, or I don't know, mechanism, engine, sounds, whatever. Or bird voice is somewhat special, so we can study, or it's a question of data availability?
Yeah, first of all, it's indeed a question of data availability, but also like those, like for example, engine sounds are probably like much easier than bird vocalization patterns that were studied in this research. So, like, I suppose it is possible, but probably it is also feasible with like general TTA models and does not require like specific models like bird vocalization generation. And talking about like combining birds, so we had an idea, for example, to create something like bird voice conversion using some normalizing flow model, for example. But for now, it is left for the future work. And yeah, it would be a great thing to do. But it also maybe it could require some like better conditioning of a time time scale to just adjust different birds' voices accordingly. So that's it.
In your future work, is absent one point to build a decoder from bird sound to text?
Yeah, it would be nice.
As a joke.
Okay, thank you, Andrei.
Thank you very much.
So, yeah, so actually, when we decode audio to text, we can further try to anonymize it so that to make it hard to guess what burst was that sound. And maybe Andrei's Andrei's work will shed a light on how to properly do the anonymization.
Right.
Yes. So the next student is Andraій Rуда. He enjoyed studying in our master thesis a lot. So this is his third year at the program, and he was supervised by Mariana Romaneshin. And Andrei will be presenting his work entitled Open Source Pseudo-Anonymizer for Ukrainian, a case study of court decision anonymization.
I'll need a minute of the technical preparation. I don't have voice songs, unfortunately. All right. Can you hear me well? So good afternoon, dear commission and audience. My name is Anдрій Rуда, and I'm excited to present my thesis work named Open Source Pseudonymizer for Ukrainian, a case study of court decisions anonymization. And let me begin with expressing my gratitude to this work advisor, Mariana Romaneshin, for her invaluable support and expertise during this project. And I also want to thank Ukrainian Catholic University for supporting my academic journey, my wife, Darina, who is present here, for her constant support and buying me an ice cream yesterday to calm me down. And finally, Armed Forces of Ukraine for their resilience and service, which actually makes research like this possible in these difficult conditions. And here's the plan for today's presentation. I will begin with outlining the motivation-related work, analysis, research gaps and questions, followed by domain justification and data collection. And then I'll highlight the way of artificial de-anonymization that we used, an anonymization solution, and finish with contributions, limitations, and future work. The motivation of this project consists of several factors. The first is that data anonymization is one of best practices that is required to ensure data privacy, especially in the view of Ukraine's EU integration. And secondly, open source anonymizers, unfortunately not present for Ukrainian, and tools that are existing for Ukrainian text anonymization. For example, one of them exists in GovTech. It's, you can, on the right, oh, sorry, the pointer doesn't work. Okay, it works. On the right side, you can see the certificate of intellectual property of tool called Akula that is used to anonymize scored decisions, and we try to reach them, to tell us more about the approach to measure the performance of their solution. But unfortunately, our request was rejected despite this tool used to protect our own data in court decisions, for example. So yeah, current tools remain inaccessible and are proprietary. And a bit of background, so anonymization, by anonymization, we usually mean the removal of information in any data source that allows to identify a person directly or indirectly, but it could be also defined differently by other regulations. For example, some regulations define it as the identification when the process after which data can no longer be attributed to one particular person, and pseudonymization when the process after which data can no longer be attributed to a specific person without additional information. For example, after your pseudonymization, you keep like the data mapping of before and after, and then engineer your data back when you need it for any other task. And in this work, we also mentioned synthetic data anonymization. It's a way to imitate real-world data without disclosing personally identifiable information. And most existing anonymization tools, they heavily rely on named entity recognition systems. For example, Microsoft Presidio and TextWatch, and they usually combine NER systems with rule-based methods to anonymize data. But for example, two most popular tools, they do not support Ukrainian at all, and they don't have any public data sets. There are NER models that work with Ukrainian. For example, NER UK is a native tool, and there is a manual labeled data set it was trained on, and there is Gleaner and some other NER systems that are like language agnostic, dear short NERs, but unfortunately they also don't provide a data set. And when measuring performance of anonymization, there is a great paper called No Intruder, No Validity. It proposes TILT framework, so it's an acronym, and it consists of three main factors. One of them is technical tool evaluation, when you measure your anonymization with metrics like accuracy, precision, F1 score. There is also second factor, information loss, how much it answers the question how much the anonymization affects the performance of downstream tasks on top of this data. And there is also the anonymization risk factor. This paper proposes conducting an intruder test when you ask someone who doesn't have any special knowledge or skills and tools to re-identify a person back. Yeah, the identification risk. And after literature review, we identified 3 research gaps, and all of them are due to absence of public high quality anonymization data sets for Ukrainian, absence of open source anonymization tool for Ukrainian, and the absence of standardized evaluation or benchmark for Ukrainian. In addition, this is me. In addition, our study is guided by 3 primary research questions. Question 1 being, is it feasible to generate high quality anonymization data set synthetically? Question 2 being, can the available open source tools be effectively adapted and used for anonymization tasks in Ukrainian? And the third one is whether we can adapt TIL framework for anonymization to evaluate anonymization of Ukrainian tasks. And this question basically shaped both technical direction and methodology design for this project. And speaking of the domain justification, when selecting a domain and data resource, we decided to stop at decisions of Ukrainian courts, which are published in anonymized form. It means that if we can synthetically anonymize them back, we'll obtain a labeled data set. So we'll be able to measure the performance of anonymization tool. And moreover, there is an anonymization paper for English language. It's called Text Anonymization Benchmark Tab that basically measures anonymization tools in English based on the data from the Court of European Court of Human Rights, so we can compare the results. And this is what we did and collected all court decisions for 2024, resulting in almost 8 million court decisions in total. Court decisions are usually templated. Every court has sometimes a set of their own templates, so we used min hash to deduplicate this court decisions, resulting in 41,000 of court decisions. And after the analysis of the subcorpus, which is actually the duplicated one, is published on Hugging Face and by us, and we decided to create a subcorpus of data to avoid court decisions due to overdue of utility bills and some common sense cases. So we resulted with 30K of Supreme Court decisions, and then deduplicated them as well and obtained a subset of 5,000 deduplicated court decisions that is also published on Hugging Face for future needs. And here's a data example. A few comments on this. You can see that there are 4 entities in court decisions. One of them, osoba, is an adressa, which are straightforward. There is also information and number entities. And these are a type of ambiguous entities. For example, under information, you can expect an organization name, dates, email, website, like basically anything. So you have to guess based on the context what is behind this entity. The same is for number. It can be any other number, for example, identificazione number, phone number, car license plate, and so on. And it's also important to mention that this is an example of administrative proceeding, and you can see that information that relates to an organization, for example, a number, or it's an index, but the full address, some numbers, money numbers, and so on. They remain public in an administrative proceeding, but in a criminal proceeding, this will be private, so this will later impact the performance of our solution. And basically, to synthetically anonymize data like this, we created a solution that tries to accomplish these 5 requirements. One of them is that all entities with the same ID should be consistently de-anonymized. Then, and some misspell on the slide, sorry. And then number and information entity should be replaced with likely structures. So we have to guess what's behind them. Then address should be replaced with a real Ukrainian address from the database that we obtain. And sub-entities should be replaced with full people names that agree in grammatical case and gender throughout the core decision. And to ensure more or less realistic substitutions for a person, and avoid some LLM biases, for example, we developed and published a name frequency dictionary that is under Lang UK organization. This one is built on top of Lemmatized Supertext corpus and was filtered out with Wikidata and Vastum dictionaries and later was denormalized. Normalized, sorry. And here's a high-level overview of the synthetic denomination solution. You can see that we have a function-based rewriter that we powered with a set of functions defined in the code, but we let this rewriter call these functions while rewriting the text, and instead of creating its own substitutions, we use these functions and available resources to generate realistic substitutions. For example, to generate name, we let LLM to provide a gender attribute for realistic substitution based on the context. And you can see that our output for synthetic generation consists of 3 main blocks. Analysis block, when we let LLM analyze the relationships between entities and the general context of the core case. The render text, when a model rewrites a text and replaces the entities. And replacement maps, for example, you can see that Osoba 1 was replaced with Ivanenko Petro Viktorovich. Its grammatical gender is male and the grammatical case is nominative. We later used this block to evaluate the synthetic deanonymization performance. And to evaluate that, we manually labeled 60 text sampled from Supreme Court decisions, and we manually labeled entities by class, for example, case and gender for Osoba, PII type for number, and entity type for Informatia. And on this slide, you can see the performance of synthetic de-anonymization. So, for example, a person case classification report tells us that weighted average F1 score for this type of data was 0.82, and for person gender, it was 0.81, which is pretty high. And for number entity, the F1 score is 0.87, and for information entity, you see that we identified some classes of it, and it was 0.84. And here's an example of the data. A few comments on that. You can see that this text mentions kids of the same person, which are son Osoba 4 and daughter or maybe son. It's not clear based on the context. It's oh yeah, it has a daughter actually, Osoba 4. So the daughter gets replaced with Melnik Alina Oleksievna, and the other kid gets replaced with Melnik Sofia Oleksievna. So the only difference is the name, and the last name is the same, and the patronymics is also the same, as well as, for example, this core case is held by Odesky Apelacyjny Sud, and the address in this core decision is also localized. So we do have the Belgorod-Dnistrovsky Odesky Oblast as well. And now we actually can use this data to test and develop our anonymization solution by integrating current state-of-the-art NER into Microsoft Presidio. So it's just a framework which has some default settings, but it can be customized. And we also extended Presidio rule-based recognizers with with a set of custom Ukrainian-specific ones. Here's quick overview of the anonymization solution. So you see it primarily consists of 2 steps. So the one is the analyzer, which basically detects the entities. And in this analyzer, we replaced an NR system, and NR is responsible for detection of person, organization, location, and daytime entities. And also there is a set of rule-based recognizers. Ukraine, for example, it's just some of them on the slide. So you can see Ukrainian IBAN, tax ID, ID card recognizer, and so on. And also there is a custom procedure anonymizer. The anonymizer's role here is to replace detected entities. So this is the entity of person, for example, here, and to match the core case and later evaluate the accuracy, the performance of the anonymization, we make it specific to our domain. For example, person gets replaced with osoba, location gets replaced with address, organization with information, and so on. And as a result, we receive an anonymization text. For example, you see that Melnik Alexei Sergeyevich gets replaced with osoba, the organization. So it's here Odesky Sud gets replaced with information, date gets replaced with information, and so on. You can see that there are obvious drawbacks of this solution. For example, we don't differentiate between a sensitive PII type and the one that should not be anonymized here. For example, it's obvious that court shouldn't be anonymized. And to measure the solution, what we did, we actually tried to adopt TILT, as I mentioned before during the literature review. So for technical tool evaluation, we measured precision recall and partial recall. For information loss, to measure that, we used perplexity as a proxy. That is actually the likelihood of the text. But unfortunately, due to lack of time and resources, we didn't conduct the intruder test and the anonymization risk. So it's left for future work. And right now you can see the results of technical evaluation. So a few comments on this as well. You can see that the recall for names is pretty high, being 0.85. However, not all names get anonymized, that's clear. But the precision for this is 0.6. This is due to the fact that there are judges' names in court decisions, and they usually also not anonymized, but we also didn't differentiate between what's the role of this person in the text. So we wasn't anonymizing that. And for example, for address, I will comment this one. This is due to address and information. You can see that partial recall is pretty high, being 1.0, but actual recall is less than that, and it's due to the fact that information entity is over ambiguous, and it can have many types under the hood, and as well that current NAR doesn't capture all address formats, and we don't anonymize. We only partially anonymize that, and that could be and that could create the anonymization risks later. And this slide is special. You can see the detective sign on top of that. That means that this is a slide to address reviewers' comment, and a reviewer asked to compare it industry-wise. Unfortunately, we didn't do the comparison in the paper. Due to the lack of time, and but we can see that the TAP paper that I mentioned at the very beginning has similar results. They also use procedure-based system. However, they also have other solutions, but the one that is comparable and built on top of the procedure, like their comparison, I cannot say that we've beaten them due to the fact that their data, they were evaluated on English data, and they just can have different distribution of entities, and like the language context can be different, but it's good to see that we can at least try to adopt the solution from other languages and get similar results. And another slide is the measurement of information loss via perplexity. So you can see that comparing the perplexity of original text and synthetic text, it doesn't like bump too much, but comparing the original text or synthetic text with pseudonymized text, we see that it increases like twice or something like that. So we can clearly see that we over-anonymized the solution due to the reasons mentioned before. And as a conclusion, I want to say that we were able to fully achieve two of the research questions. So we created an anonymization data set synthetically and published them. Also, we adopted Microsoft procedure by integrating Ukrainian air and developed custom recognizers. And we also only conducted technical analysis and utility loss calculations, but we didn't explore and implement for identification risks. So it's to sort completed. And as for contributions, we published 4 resources. So it's the actually 2 corpuses of the duplicate anonymization Ukrainian court cases for 2024, an anonymized corpus of 250 artificially anonymized court cases, a frequency dictionary of Ukrainian names, and as of tools, we described the synthetic de-anonymization pipeline for Ukrainian, and also we published an open source tool, the procedure adaptation for Ukrainian for text pseudonymization. And the next is limitation of this work. So the frequency dictionary of names may not be accurately representing the real distribution of names due to the fact that it's built on top of UberText data. And this data basically a compilation of news and social media resources, so it can be impacted by that. Also, partial pseudonymization of compound entities, particularly address, it creates a possible and potential re-identification risk. And we didn't conduct entity merging that is originally done in court decision. And an intruder test was not conducted. And as for future work, what we can recommend, so the one would be the development of NERS system that is only specific to detection of PII type and not general per snare. Unfortunately, we don't have that. And we can also refine rule-based recognizers since we only covered most popular of them, but like further analysis of these PII types can also help to refine the quality of pseudonymization. And also we can work on improving the representation of real word classes in the synthetic data set to ensure a bit more realism, and conducting, of course, the identification risk analysis would also benefit the solution, and also expanding to other domain. So yeah, that's it. And now I'm very thankful for your time and attention. I'll be happy to answer your questions.
Okay, so
25 minutes.
You're lucky with the head of the program. I always have questions.
And a tool.
And they are not from the notebook LM.
That's great.
Yeah, so maybe I will start my another favorite question. For example, if we omit the importance of the task, that is no doubt important to have a pseudonymizer, and we look at the computer science side of your diploma, because you are defending the qualification in computer science with specialization in data science. Could you please list the contributions of the work or what was done in the context of the computer science and data science?
Yeah, thank you, Ruslan, for your question. That's a great one. So I think that we cannot underestimate the importance of having a good quality data set, that's for sure. So this is what we've created. And we also did a lot of data analysis to create this one. And also measuring the state of current situation is also important. So we other generations can iterate on top of our research. I think that after this one, they will have a good baseline that they can work with.
Okay. My next question is, so your work is entitled Pseudo-Anonymizer.
Yep.
A case study of a core decision anonymization. And as far as I understand, one of the important tests is the ones that you listed as a limitation. Intruder test was not performed. How significant is this omission for evaluation of the robustness of this anonymizer that you proposed?
I think that like being honest, it's very significant, I would say, since we are working with sensitive data, right? And unfortunately for our situation, we were only able to conduct the intruder test at the very beginning of the pipeline, and the major contribution that we did, and it maybe the whole work consisted of 70% of time being dedicated to the generation of the data set, which wasn't existent for Ukrainian. And because of that, the intruder test is for sure very important, but it's also a resource-heavy task. So you have to involve volunteers or maybe investigate a way to do the automatization of the intruder test. Yeah, but unfortunately, we were limited in the scope, and at the very end, we had to neglect something in the scope.
Okay, and my next question is about frequency dictionary. How the fact that this frequency dictionary may not reflect the actual distribution, the actual frequency, impacts the performance of your system.
So let me get back to previous slide. So as you can see that we like the named frequency dictionary is targeted to person class, and you can see that I cannot say that like this recall of 0.85 is low. So I think that it's still okay to have this way of the data compilation and work with names from news and social media sources. So
yeah, my question is not more less about the metrics, but about, for example, practical applications. If your system is deployed and we have some, for example, in some other countries, they don't even have a data set to extract those frequency dictionary, and they have even less developed frequency dictionary. So how this would impact the system?
I think that one day there will be a person that will name their kid Bayraktar or some other imaginary name. So there will be always like unique names that exist in one sample. Like since we like I don't think that it really impacts the quality here, and I think here it's about the compromise, because we also try to reach the Ministry of Justice of Ukraine that operates this data to publish like real frequency dictionary of names. This data is not sensitive, and the request was also rejected. So like it's not everything we try to do to ensure the realistic distribution of names, and especially in the view that there were DIA outage and data leakage recently, they rejected that, and they argumented that with the complication and security regulations. So despite I personally think that the distribution of names is not very sensitive information.
Okay.
But, yeah.
And
Thanks.
probably my last question is about maybe comparison with anonymizers, maybe for other countries, for other languages. So how far are we from, I don't know, the most developed country in this setting? And do they have open source data sets? What is the size of the data set? Something like that, just to understand the gap. Where are we now, and where it would be nice to be?
Yeah, so the anonymization topic, to my personal opinion, is under research in a lot of countries and a lot of languages, and English remains the leader of the research. And we didn't unfortunately conduct the comparison in other languages. It didn't like during the literature we didn't identify very extensive comparison in other languages, and only this paper was available to our knowledge.
Can you get back to the example of the anonymized text, please?
This
Yes,
one.
this one.
Yeah.
Yeah, so is this manually de-anonymized?
No, not at all. This is one of the, so to one of Ruslan's favorite questions previously, this one was manually selected by not due to it being I know something special, but due to the fact that it's easy to illustrate here the contextualization of the approach.
And once again, how you de-anonymized? So what was the main method for the anonymization?
Oh, sorry. So we actually researched two approaches, and one.
So you use this prompt engineering for GPT.
Yeah. So we actually were rewriting the text, but here we powered the rewriter with a set of functions. So GPT can call these functions, and for example, instead of generating a name, it can give us a request to generate a name, and then we will return a name in all grammatical cases. So GPT can later use all of these cases to inflect them in the case and use them. And for example, we also were relying on GPT in terms of the contextualization of address. So here we not just randomly generate an address, but there is an
attribute. How do you relate on the date? So for instance, is it possible that there will be a case that senior, like from the context point of view, a senior person can get a birth date that is later than the younger person from the contextual point of view?
Yeah, that's true. So for the date, the LLM was providing us arguments of a range. it thinks it would be reasonable for this person to.
So LLM analyze and provides the range.
Yeah, for example, there is an analysis block here, and it in here it tries to build the relations between entities. For example, there is father of.
Okay, thank you. And can you get back to slide number 22? There was objection from your reviewer that you do anonymization and you forget those differentiation between
pseudonymization and anonymization.
Different persons. So we have this different persons, Melnikov C, Melnikov M, but both they have like become osoba.
Yeah.
Why is that?
So like due to the constraint of procedure per plan, it wasn't possible to customize it like easily and in a reasonable matter of time and merge the entities. However, we also were trying to do that, but
from the contextual point of if I try to use your solution for anonymization for the court texts, court protocols, and they use it doesn't differentiate between different persons, and all persons become like osoba.
Yeah.
So would it be useful?
Yeah, it's also the downside of this approach, of course. However, that pseudonymized text and why it's called pseudonymization is because the result of this
I understand,
procedure.
But from the point of view of application, my question is. So I'm reading, and it's the whole like different persons, they become like a person.
Yeah, that's true. However,
so probably when you talking about your second research question, when you're talking about this implementation into those MS tool, that, yes, you implemented, but what for? So it for the court application, it doesn't make sense. It's unapplicable. You see my point?
Yeah, so the primary reason to go with the solution was to evaluate the state of tools right now and not just replace existing solution in court decisions and so on. And none of the anonymization solutions right now.
It's enough. Thank you.
Doesn't merge entities.
Any other questions?
Yep.
Oh, wait a moment. We should have a break till 4 p.m. We will continue at 4 p.m.